All right, let's try and get into 6.3 today. This is still dealing with rational numbers. Those are our rational numbers, but we're going to deal with multiplication, a little bit of division, and probably some exponent work in this. Okay, so this is kind of a long PowerPoint, so we're going to try and get through it pretty quick. Most of you should remember, hopefully, how to multiply fractions. That's what we're talking about. Remember rational numbers, except remember our rational numbers have to be in A over B form. So if I want to multiply a whole number times a rational, so here's 3 times 3/4, that would be 3 of them. Okay, that's the repeated addition method. So if I have 3 3/4, 1, 2, 3, and add them up, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/4, or so you have your improper version or your mixed fraction version, whichever one you prefer. Okay, you do the same thing with parts over whole, or parts of your area. Same group applies. So you can still do some of the same things. Now, how do I multiply rational numbers? Okay, well, you might have learned it as multiply the top, multiply the bottom, then reduce. Okay, sometimes some of the easiest ways that we do things. Okay, so here we have an example. Okay, if 5/6 of the population of a certain energy are college graduates and 7/11 of the city's college graduates are female, what's the fraction of the population is female? So basically we're taking 7/11 of the whole population that went to graduate, that were college graduates is 5/6. So we multiply 7/11 times 5/6, which if you multiply the top, multiply the bottom, you get 35 over 66. And if that's reducible, in other words, if you can factor out a common factor, you would do so. Okay, this does not. Okay. All right, so multiplication rules for for rational numbers. Okay, multiplicative identity, the same thing as any multiplicative identity. You multiply any rational number by 1, you get the same answer. Okay. You also, but here you have the multiplicative inverse, or what some people call the reciprocal rule. The reciprocal, remember, if I have a rational number a over b, its reciprocal is b over a. It's the flip, not the opposite, but the flip. Okay, and if we multiply reciprocals, a over b times b over a, we'll always get 1 because we multiply the top, a over b, or so AB over BA, which reduced to 1. Okay. Now, can you have a distributive property over either addition or subtraction? Remember, if it's over addition, you need a plus sign. If it's a subtraction, you need a subtraction sign. All right, so how do I go about dealing with this? Okay, well, let's look at it for a second. All right, so what we got here is we're going to distribute a b into this fraction, which you would get a times c, b times d, that's this, a times c, b and d, plus ae over bf, okay, which would be done. Okay, you might actually have it written as ac over bd, none of that reduces, plus ae over bf. And again, none of that reduces. And you cannot add those because they have different denominators. Okay, same thing with the subtraction sign, except if it's subtraction, you'd have the subtraction there. Okay, all right, so that's distributive property. Okay, equality property means that if I can multiply a rational number to the first rational number and to the other rational number, if the original rational numbers were equal, then the new rational number is going to be equal. If I multiply the same thing to both AB as I do to C over D, then you get the same rational number. Okay? And the same thing with if I'm multiplying using with inequalities. If I have two rational numbers, say this rational number here is greater than this one, and I multiply by a positive, then they're still going to be greater than this left side still be greater than the right side. If I multiply by a negative, okay, now remember, okay, this means negative. So if I'm multiplying by a negative, notice the symbol switches, and that's that inequality rule. Okay, so that does still apply. Property of zero rational numbers when I multiply still gives you 0. So same old rule. All right, so if we take a problem, it says a bicycle is on sale at 3/4 of its original price. If the sale price is $330, what's its original price? Okay, so if I want to take 3/4 times its original price, which would be 3/4 x is equal to 300. Remember, this is the sale price, x is your original price, and we want to solve this. Okay, so the way the textbook and your examples will play it will be this. You're going to multiply both sides by its reciprocal. Okay, so the reciprocal of 3/4. Okay, now I'm going to show you something that the students probably don't like to see. Students don't like fractions. Ugh, right? Okay, so the way the book uses, they use the reciprocal. They take the reciprocal of this one, which is 4/3, multiply it because this whole thing ends up being 1, so I get 1x. But then you have to do it to this side. Okay, well, that's okay. Now, what I'm going to tell you is something the kids like, and that is getting rid of fractions. Multiply by its common denominator, which would give you now 3x. Now, it does make bigger numbers. 0 to 12, 13, 20. Then divide by 3. And you get x is 440. Okay, it does work that way too. Okay, and a lot of kids wonder. I like the reciprocal rule because I'm okay with fractions. But if you have a student that doesn't like fractions, this is the way to go. I call it the fraction phobia rule. Okay, kids that don't like fractions, I use this rule with them. Get rid of the fractions by multiplying everything by a common denominator. It does help so many kids that way. Okay, all right. What about improper fractions? Well, if I'm using improper fractions, this says using the distributive property. Okay, I'm not a real big fan, but that's okay. It works. Okay. There's two different ways using improper fractions here. I guess I misunderstood how they were doing it there. Sorry. Okay. This is the way I like doing it. Okay. Change it to an improper fraction and then multiply. This distributive property, it does work. Okay. But it does confuse, and the fraction kids don't like it too much. Okay. Because you're taking 2 of these and you have to multiply this by 2. Okay. So I don't know. It is 6 of one, half dozen of the other. It does work. Okay. All right. So division of rational numbers. How many halves are there in 3 wholes? Okay. So if I have 3 wholes, well, how many halves of these? Well, there's 3 wholes right here. How many halves is that? Well, 6. Okay. One of the biggest confusing things. Okay. And I'll tell you, we'll get to this in a second. But one of the biggest things that confuse kids is something like this: 8 divided by a half. Most kids will say 4 when the answer is 16, because there's going to be 16 halves that make up the total of 8. If you take 16 halves, put them together, you get 8 wholes. So, same thing. It says how many 8s are there in 3/4? Okay. So, how many 8s are there in 16/4 or in 3/4? Well, there's 6 of them. If you go and divide this thing up into fourths. So there's one. So this would give you your fourths. How many eighths are there? Well, this is a fourth. Divide that in half. That one in half. That one in half. That gives you eighths. 1, 2, 3, 4, 5, 6, 6. Right? So using the pictures does help a little bit in the description of them. Okay. Let's use the number line. How many 3/4 are there in 7/8? Okay. Well, if there's 7/8 here, okay, so here's your 7/8, okay, and you take 3/4, there's 3/4, there's 1/4, 2/4, and 3/4. Okay. All right. So what is the rule for division of rational numbers? Okay. So here we have our rational numbers. We're taking AB dividing by C over D equals EF. Okay. It only works if CD times EF will give you AB. Okay. So when two fractions with the same denominator are divided, the result can be obtained by dividing the numerator of the first fraction and the second fraction. To divide fractions with different denominators, we rename the fractions so the denominators are equal. Okay. So oops, trying to see here. Okay. Now, this is not normally the way a lot of them are going to be teaching you things. Okay. Most of them, and I might be working a little ahead here, but if I was to take two fractions, the same denominator, so let's say 4/5, and we're going to divide it by 1/5. Okay. It says you'll get your answer by dividing the numerator of the first by the numerator second. So the answer, if they say this, is going to be 4, 1, so the answer should be 4. Okay, which is a fine little trick. Okay, it says here to divide fractions with different denominators, we rename the fractions so the denominators are equal. Okay, not really sure why they give you this. Okay, because in this process, I think they're teaching, this might be a Common Core thing. I think they're trying to teach you so that you have a common denominator all the time, okay, to help things out, okay? But let's just take the idea 5/7 divided by 3/8. Okay, instead of getting the old common denominator, okay, and this might be, I can't remember if it's a little farther into the slideshow, okay? What we get a lot of, what you should, and what Texas will have you do, is take the first fraction, and then we're going to change it to multiplication. They do it here, but then you're going to reciprocate or reciprocal this one. And this way, when you multiply, you get 40 over 21, which will be my answer. Okay, you get there by doing all this, but common denominators are hard enough adding and subtracting. Don't know why you want to do it here too. Okay. All right. Let's get that one here. We're gonna go here. How many 3/4 minimum public service announcements can be allowed in 36 minutes? Okay. So notice they use the rule here. Okay. 36 divided by 3/4. Because you're trying to find how many 3/4, 45 seconds basically. And then so you're going to take 38 or 36 times its reciprocal and you get 48. So they use that process there. Again, like I said, finding the common denominator is kind of a wasted time. Okay? So we have 35.5 yards of material available to make towels. Each towel requires 3/8 yards of material. So how many 38s are there in 35? Okay, that's kind of, so this is what we're going to divide to. Okay, so when you do that, these mixed fractions change to improper. That would be 71/2. Remember, 2 times 35 is 70 plus 1 is 71/2. And then you multiply it times 8/3. Okay, so we're going to multiply. That's 284/3, which in this case, is this going to be a good time to make mixed fractions? Yes. Okay, because they want to know how many towels are made. 284/3 doesn't tell you how many towels. So now you change it back into a mix. It has 94 2/3. Okay, so question is, how many towels can be made? Well, how many towels is this? Well, the answer would be 94 towels. Why is it not 97 or 95 towels? Why do we not round up? Because that 95th towel can't be made with only 2/3 of the material. Okay, it's 2/3 too small. Well, actually, a third too small. Sorry, 2/3 is not enough to make a whole. So this is one of those times where you actually round it down. Okay, how much material is going to be left over? Well, 2/3 of it's left over. So it says basically it's a 1/4 of a yard. I'm not going to ask you anything like that, so we're okay. All right, so I'm going to let you see this. You can look at this here. Now, this is another way that you see some things getting done. Okay, dividing 37/2 divided by, now this, if I look at this, and we're going to stop it here, not just because of the problem, but because of what kids hate to see. This would freak them out. Okay, how do we divide that? Okay, some of them don't see it. You might even also see it as, what's that? 75/2 over 5/4. They might even hate that look. But when you show it to them this way, that's 75, right? Well, no, 75/2 divided by 5/4. Now it's something, oh wait, I can do that. We can do the reciprocal. 75/2 multiplied by 4/5. Now, can we make this a little bit easier on us? What we're going to do is we're going to, instead of multiplying the top and the bottom, showing you one thing that you hopefully can get them to learn is reducing common factors. Well, 5 and 75 have a common factor. That factor is 5, so divide that by, you get a 1. Divide this by 5, you're going to get a 15. And then the 2 and the 4 have a common factor of 2, so 4 divided by 2 is 2, that's 1. And look at this, you end up with an answer of 30. Okay, so again, it's an easier way of doing things. I just like to show you that students would like, they would say on something like this, they would say ugly. Even here, they would say ugly. But for some reason, they're okay with this. Okay, so just as an FYI, that's kind of how students talk and act. All right. And that's kind of showing you some of the same steps. Okay. All right. Estimation. We're not going to talk about estimation. I don't really go too much into that because I need to get into your exponent rules, because exponents also deal with multiplication. Okay, so we want to make sure we get to all your rules again. Exponent rules. Okay, we've talked about them before. A to the 0 powers. Anything to the 0 power is 1. If I have a negative exponent, it goes to the bottom. If I have same base, Then I add my exponents in multiplication. If I have same base and division, I subtract my exponents. If I have an exponent to an exponent, we multiply. If I have an exponent outside of a rational number, so now here we're talking about the rationals. Both the numerator and denominator get the same exponent. Now this was the one that interesting because if it has a negative m, okay, what happens is it flips your exponent or your rational number, so now it's b over a, and then they each get this, okay? So in essence, what they don't show you is you have this, you're going to flip it, and then you end up with that. But now it's just going to be b over m over a over m. And then if you have two things multiplied inside with the exponent outside the parentheses, and that's important, it's going to be outside parentheses, everything inside, each of them get that exponent. Okay? Now, if this is a to the first, that's why you get the m. If it's b to the second, this would have been 2m. Okay? So, depending on the actual problem. Okay? So, we're going to use those rules. And we're going to talk about some of these exponents. Okay, so using the exponent rule. So here I have the opposite of x to the negative 2 power. Okay, which means it's not going to be the opposite of x to the negative 2. Okay, what it's going to be is this whole thing is going to go down below because of the negative exponent. And then I square it. So now negative x times negative x is positive x squared. Right? Now, what happens if the negative's outside the x? Now, these are two different problems. Okay? This is where we have to look at this. This, like I said, brings this whole thing down, and you get over here. Okay? Notice what's different between these two here. There's no parentheses. Okay? So, it's like saying this. Only the x gets the negative 2, which means only the x goes down to the bottom. Notice that the negative still is outside parentheses. And then once you get it down to here, now it gets here, negative x. Okay, so depending on where the parenthesis is, depends on what do you do with it. Okay? All right, so that just kind of goes through that same problem. Okay? AB to the negative 1 is not equal to AB to all to the negative 1. Why? Because of the parentheses. Okay? The negative 1 here only goes with the B. The negative 1 here goes with A and B. Okay? Hence why they're not equal to each other. All right, so how do we deal with these? Well, let's take some examples here. Okay? Notice here, the negative 1 would actually, get my toe here, the negative 1 multiplies to this, and then it also multiplies to this exponent. That's why you get the two positives. Okay? That's how I would do that problem. I wouldn't do it the secondary way. Now, here's the thing. Because of the plus sign in example E, this does not go to everything. Okay? What's going to happen is you first have to make this a squared on the bottom, and this one b squared on the bottom. All of that to the negative 1. Okay? Which makes it a really ugly problem, because now what's going to happen is you have to show you here. Okay, here's where we're at, and then you actually have to do it. Now, how do they get from here to here? Okay, back you up a step a second. How do you get from here to here? Common denominators. Common denominator is a squared b squared, which means this one up here needs an a squared, or b squared, sorry. This one needs to be a squared. Okay, that's where the a squared and b squared. And then you have to flip top and bottom because of the -1 exponent. And that's why you get to where that's at. Now, what they're telling you here is that, oh, they're telling you this is not equal to that. So anyway, that's how you get from one of those steps to the next. All right, so let's look at these. All right, so how am I going to deal with this? Okay. Now, the easiest way is by using exponents. Okay. Not really sure why they put this in here, but this is kind of one of the last couple things they have you do in this section. You want to change these to smallest exponents you can. So 16 is 2 to the 4th. 8 is 2 to the 3rd. So what you have to do is what we say, use the same base if possible. Okay, so this would be 2 to the 4th all to the 2nd power times 2 cubed to the -3. Now if I use my exponent rules, that's going to now give me 2 to the 8th power times 2 to the -9 power. If I use my exponent rules here, I add these together, I get 2 to the -1, which I can't have a negative exponent in my final answer, so that brings it down to the bottom. So I get 1/2. Right? Now, this one you would never do with your elementary kids. Never. And most of the stuff you're not going to do elementary, maybe upper level junior high. Okay? So I'm going to go ahead and go through these. I do want you to be able to do letter D, sorry. Okay? Because I think letter D is important just to know some of your exponent rules. Okay? What I would do, basically what you're doing here is this, it's not too bad. Multiply this times this. Okay? Which would give you x to the -12, x to the +8, because 2 negatives give you 8. Negative exponents go down to the bottom. Positive exponents stay on the top. And you get this final answer. Okay? So that is the end of 6.2.